One of the concerns that many have in digital inventory is how confident can we be in that data?
Tree sampling really hasn't changed very much since the early 20th century.
I have a textbook from 1905, and in that textbook are examples that I still use to this day to train students on how to measure and sample forests.
The first time I pulled up a lidar data set, it completely blew my mind.
You have a lidar sensor, it's on an aircraft, it's flying over your land. That sensor is shooting down laser pulses. I would think of it as painting your forest with lasers.
Traditionally, estimating these forest attributes has been done through sampling. You take a random sample, you measure elements of the population, you take some averages, and you extrapolate.
We have tested many different instruments, we've tested many different codes, and really when it came down to it, there wasn't a tool out there that allowed us to do to the forest what we knew needed to be done. Now, rather than extrapolating from a sample like we have for years in the past, we have the ability to create a digital inventory of every single tree. There's many forests, thousands of acres across North America, millions of acres, that we really don't have an operational inventory. We really don't know what's out there. I mean, half of the challenges that have driven us to learn what we've done and apply what we have on the forest is the ability to see the forest for the trees and actually identify where health challenges, fire risk, problems exist. So Forest View is a suite of software that leverages machine learning, deep learning, and in some ways quasi-artificial intelligence to look at a three-dimensional data cloud of lidar and a number of other inputs and generate from it meaningful and operationally useful tools. For example, a digital inventory from Forest View would provide an inventory of the trees across that landscape, but it would also provide roads layers, streams layers, canopy densities, wildlife habitat insights, digital elevation maps to a 12-inch resolution and finer, and a lot of other products that help not just foresters, but any land management professional, and it's at a reduced cost.
Using lidar or other remote sensing, we have the capability to look at that finer spatial resolution.
You can see the individual trees very clearly.
We call it just high resolution, but it is a custom specification of lidar settings, and they are set in such a way that it accentuates the within canopy and vegetative structures that those lidar pulses pass through. That's quite a bit different than standard lidar that you would see that's collected by a state or a county or a federal agency. Those are typically set up to capture the ground. What we've seen from the Forest View software is exciting beyond just enumerating a single tree because it increases the capacity. A forester is not going to be able to measure every single tree across a landscape, and this technology now allows us to get measurements that are as accurate or better than a field forester across the entire landscape, so we can actually see the forest for the trees.
One of the concerns that many have in digital inventory is how confident can we be in that data? We need to have strong confidence that the metrics, what have you, whether it's for fire, for fuels, for forest inventory measurements, we need confidence in those numbers because management decisions are going to be made off those numbers. And so we need to have that confidence that when we're making a decision, we're making the right one. And again, it's not just from a production perspective, but it's also from a forest health perspective.
aerial LiDAR over 1.5 million acres in the southeastern US. We chose an area in East Texas that had a plantation of loblolly pine that was near harvest age. We had flown LiDAR over it. We had not done any field data collection over it. We fully processed through Forest View the digital inventory product, and then we went down there as a blind test to actually stem map every single tree, as well as field cruise them with some of our best field inventory foresters while standing, then physically follow those trees with machines right there as we were on site, and tape measure diameters, heights, and measure taper while they were on the ground for full trees, and do the calculations then to see how close the produced LiDAR-derived inventory was from Forest View, as well as how it lined up with an in-field full stem map cruise, and then the actual trees laying on the ground.
We showed up to the site. We took high-resolution GPS locations to every tree. We also recorded diameter, height to live crown, total height for every tree on the site.
So we are out here using traditional measurement techniques to validate the measurements that are brought from a LiDAR flight. Essentially, what we're out here doing is creating a physical stem map to then compare with our LiDAR data set. And that provides a validation against the LiDAR data set.
When we were done with that, the logger came in, laid the trees down for us. Once those trees were on the ground though, then it comes to actually verifying what we measured standing on the stump. So that's the felled tree data. So we would actually stand at the base of the tree, we would account for the stump height, we would pull a tape and call a number. In addition to that, we would also get a taper diameter at 32 feet up the stem, which is pretty important for your volume calculations. We like to say every measurement that we're taking with regards to heights in forestry is more or less an estimation until that tree is on the ground.
As soon as we got the field data back into the office, it became apparent pretty quickly that the LiDAR data and the digital inventory were as accurate or more accurate than our field measurements. And we were able to validate that for our own team and for many of our clients because of the felled tree data. Actually being able to follow the trees and put a tape measure on them really gave us the confidence we needed to put all of our energy and our excitement behind the LiDAR. You know, getting those data back to the office was where really we started getting pretty excited about it, because seeing not only the tree points in GIS from the LiDAR, but then having physical on the ground data. And as we started to line those trees up and start seeing that our aerial LiDAR, our field forester measurements, and our felled tree physical tape measured measurements were within inches. I mean, if we had that across a large landscape, statistically speaking, they were insignificantly different. The way that we were collecting these data was that good. And it was fun to see that we were right.
So right now, the precision that we see in the LiDAR data sets are very high, and a lot of the times the number of attributes that we can pull out of the LiDAR data set is limited by our ability to actually go in and build those models and train those models, which takes time. We might be able to directly measure some of the attributes of the tree. One interesting one is tree taper. If we have a perfectly detailed LiDAR scan, we can actually get the exact cross-section of that tree all the way up the stem from the ground to the top of the tree.
We're measuring everything from The spatial position of that tree, we're looking at stem characteristics, diameter, crown metrics, total height of the tree, height to live crown of the tree, angles the branches come out of the tree, the size of the branches, the spacing of the branches.
The unique and very exciting thing for our team is that with an understanding of the accuracy and precision of LiDAR toward single tree inventories, that it's not only viable, but it's as good or better, plus it's scalable to an entire forested landscape.
With products such as Forest View from Northwest Management, we now have individual, distance-dependent growth and yield models. With repeat scans on our school forest going into the future, we can start to understand those growth relationships at an individual tree level.
There's still a need for people to go collect field data for validation and verification purposes. However, it significantly improves how many acres can be inventoried a year. Instead of having 20 plus field staff on the ground for an entire summer to do 20,000 acres of conventional inventory, we now have the ability to use the same 20 plus staff to do 2 to 3 million acres of inventory a year. And the cost is actually at a 50 to 60% reduction in total cost per acre. Being able to have measurements that are as accurate or more accurate than field data, but at such a much broader scale, where we have not only individual trees that cover what you would have measured with traditional sampling, you now actually have the same level of measurements with as good or better accuracy across the entire forested landscape. With the results of our study that we have now, I really do believe this is a turning point for our industry.